Hey everyone, welcome back to another video, and today's video is going to be the extension of the previous video. Let me quickly guide you through what we did earlier. Was we tried to implement the Redis clone in Rust. So we have implemented some of the basic string operations like set, get, delete, and something called TTL, an expiry variable. And in today's video we are going to extend these data structures. We will try to implement list, sets, ordered set, hashes and all. So let me just pull my tab so that I can show you what we are going to do today. All right, so in previous video we implemented some features of string operations like get, set, delete, and while setting we implemented something called TTL, time to live. Okay, so now what we are going to implement is we are going to implement list, hashes like hash, sets and ordered sets. So yeah, let me just quickly go onto them one by one. So first of all we will implement list. So in list we need to implement, imagine this as a list. So we need to implement a list so that can be operatable on both the ends, like left and right ends, like front and back. So imagine this, there is a list, it has two ends like L and R, and we need to perform some operation on both the ends. So as you know, this list, we need to implement something called L push, L pop, and we need to implement from the back as well, that is R push and R pop. So either we use something called doubly linked list, or we can take help of already available data structure in Rust, that is vecdq. So it's a queue that is operatable on both the ends. It provides some features like pushing on the front end, popping from the back and all. So we can take help of this instead of implementing our own doubly linked list. So that will be quick. So we need to implement these features like L push, L pop, and R push and R pop. And we will implement something called range. So what we are going to do is we will pass our key parameter to it, and from that key we will try to extract our range based on the two indexes kind of thing, that is start and end. So we will implement this range as well in this list. So let's quickly go on to the code base and start implementing this list. So instead of implementing our own doubly linked list, we are going to take help of vecdq. So if you want to learn about vecdq, you can go over here on the standard library, and here is a detailed documentation about what vecdq is and what are all the available methods over here. So we are going to take help of vecdq. So let's quickly go on to the code base and start implementing list. After we implement list, we will quickly jump onto the hashes, sets and ordered set. So basically these three are easy to implement because we will take help of hash sets, hash maps and vecdq to implement these features. But this ordered set is a little bit complicated because so imagine this ordered set as a ladder board like this. So you must have seen somewhere these kind of ladder boards, right, where we have users, and these users are maintained by something, a variable called score, right? So as soon as the score updates, these user get shifted to the top or either to the bottom, right? So these are the ordered set. These are unique elements that are maintained and ordered by something called score, and once this score changes, it gets reorders every time, right, like a ladder board. So this will be little bit tricky, not very much, because we are taking help of already available data structures. So let's implement list first, and then we'll quickly jump onto the others. Let's go on our code base. Let me set my keyboard over here. Right, okay, we need to tweak few things over here. Now that we have implemented this basic string operations, we need to create something over here. We need to create another file. Let's name it data structure.rs, and we will create another thing called mode.rs so that we can link these modules over here. But for that we need to rename this file. So instead of this mode.rs, we'll use db.rs, and we'll create another file called mode.rs, and in the mode.rs we'll link those files. We'll use pub mode data structures and pub mode db. All right, I think we will encounter some errors. Let's quickly re-import it. All right, let's go over here as well, commands. All right, I think we are good here. Okay, all right, now we have we did some changes. Now let's start implementing list over here. So as I told earlier that we need to implement something, this list, and this list needs to be operatable on both the ends, like from left and right, and this can be done on by implementing doubly linked list. So we'll take help of this vecdq, right? So let's start implementing these things. So what we are going to do is we need to create a struct over here, and let's name it our list, and we'll create a variable pub. So let's name it list, and we'll take help of vecdq, and we'll store our values as a string over here. All right, and what we are going to do is we are going to implement things. So as I told earlier that we need to implement these features what Redis kind of provides similarly, that is lpush, lpop, rpush, rpop, and a range. So we need to create functions here as well, like lpush, rpush, lpop, and rpop. So let's start implementing these functions. So we need to create first of all this new function that will help us to initiate the new instance of this Redis list. So let's create public function new that will return so what it does is it will simply return us the list, and that is vecdq new, right? All right, associated function is never used, of course. So yeah, another thing that we are going to use is pub fn. So we are going to implement a few functions over here, that is lpush, lpop, rpush, rpop. So as I told earlier, the list needs to be operatable on both the ends, that is front and back, and we denoted it by let me just and we denoted it by L and R over here. So L is basically front and this R is basically back of the list, right? So we need to take help of vecdq and perform these operations. So L push is basically pushing on front, and lpop is basically popping out from the front of the list, and the same goes for the back of the list, that is pushback and pop back. So vecdq provide these functions. Let me just show you what these functions are. Let's search push front, yeah, these things, right? Push front and pop from front. So as you can see, we have initiated a new vecdq over here, and we started pushing from the back, right? And we tested it out with this, and we pushed on the front as well. So it will be 10 9 0 1 2. Yeah, so we need to take, so L is basically the left of the string is basically the front. So L push means pushing on the front, L pop means popping from the front. So let's implement this thing. So let's say public function lpush, and it will take a value that is of type string. So what it does is self dot list dot, so lpush means pushing on the front, right? So it provides the operation, and we can store the value over here. And let me just copy this thing for lpop, rpop, and rpush. So as you can see, it was very simple as we are taking the help of vecdq. So let me just quickly change these things, pop, and what we are going to do is we use the function called pop front, and we are not going to pass any value over here, and this is going to return us either null, like either non-value, or a popped out value, right? So lpush and lpop has been implemented. Let's do something called rpush. We need to use pushback over here, and yeah, and for our pop it will also return us the optional string value, and we'll use pop back. All right, so let's remove this thing. All right, so it says other definition for our push. We are going to implement our pop over here. Alright, as you can see, we have implemented these functionalities that Redis provides, that is lpush, lpop, rpush, and rpop. Another thing that we are going to do is we'll implement range over here. We'll something use lrange. It will take start and it will return the vector of the values stored. So what it does is it will take self.list, and we can iterate it. We'll skip the first element, that is the start index, and we'll take only this thing, that is at the end, the index at the end minus start plus 1, right? So skipping the first start index and taking up to the last index. We will clone it and collect it so that we can receive it in a vector, right? So we have implemented these features like lpush, lpop, rpush and rpop. So as you can see, instead of implementing like a doubly linked list, we already take help of this available vecdq collection, and it provides us the features like pushing on the front and popping from the back and all. And we have implemented something called L range so that we can find the range based on the start and end index of that of the list, right? So now let's quickly implement a command parser for it so that we can like test these out from the terminal. So for that we need to go on this command and we'll start implementing over here. So on the command parser, we will implement the command parsing that we pass from the terminal. So we'll pass something like L push with a key and a value, and what it does is it will call the appropriate method on the database file that we have created, so that if we call lpush from the terminal, it will push on the data structure that we will create on the db file. So it will do something like db dot lpush or something like that. But before that, we need to implement these methods on our database on our db.rs file. So I think we need to implement that first. So let's go over here and we'll implement all the list functions from here. Yeah, before that we need to do something over here. So we need to do, if we have a db over here, let's say list, and we'll use and we have string and our list, right? So okay, and we will do something over here as well. So list, we have arc new rwlog new, and we'll do hash map. All right, so now let's implement these features over here. So let me just do this. So we'll say public async function l push. It will take a reference to self, a key and a value. So let's start implementing this thing. So we'll try to get the log from the rw log that we are using. Let's say we'll fetch that right log. We'll use self dot list dot await, right? So it will be mutable. And now we will check if the key is available on this map. So list map, we'll check it by entry. We'll have a key, and if it's not available, then we'll insert with the new function that we created. So we have lpush created, right? And we'll insert the value. So we have implemented this. Okay. All right. So we have implemented lpush. The same goes for rpush as well. So let me just copy it. We need to name it rpush. We need to do rpush. Now let's implement lpop. Now let's implement lpop and rpop. So it will have self, a key, and it will return this thing, option of string. And again we need to find out, we need to take the right log from that rw log that we are using. So it will be self dot list dot right await, and what we need to do is we'll use something called list map dot get mute, and we'll use our key. And if we have something, we'll simply use list we have a list over here, right? Because we are using hash map to store that list with a key. So we will have a list over here. So we'll use is list dot lpop, right? Lpop, and it will return the option string. Okay, so we have something error over here. Okay, found string expected unknown. So I think let's implement else part as well. Let's say none. Okay, get mute, it takes a string, and will it be something like okay, is a mutable and is not declared as mutable. So let's do this mutable. Let's see how it goes. All right, so let's copy this to implement rpop. Let me just, okay, so let's do this rpop. And all right, so let's implement another thing that we have implemented on command parser, that is L range. So let's implement this thing. Think fn L range. So it takes a self, a start of type usize and usize and a key of type string slice, and it will return the vector of string. So we need to perform few things that is already common on all the operations, that is getting the right log. So it should be mutable list map. So we have self dot list dot right dot await, right? So we do if let some list list map dot get mute key, and let's implement the else first none, and if we receive anything we'll simply say list dot l range. We have start and end. So this has been implemented, the l range, l pop, l push, r pop and all. Let's quickly go and implement the operations on the command parsers as well. So we need to do something like db.lpush over here. So we'll simply do so we need to also implement this these Redis-like response format, right? So we'll do that as well. Let's quickly do this thing first. db.lpush, and it take self a key. So but the key is of type string, right? So what we need to do is key dot, we can do something like this, and value dot to string dot await. Does that make sense? We need to perform this, right? Okay, yeah, this is good, this one. Let's copy this thing, we'll paste it over here. All right, so lists, this lpush has been implemented. We will, as soon as we encounter lpush with some key and value, we will call the db.lpush method that we have created. It takes a key and a value. It's an async operation, so we need to like implement await over here, and once it's done we will simply return okay from here. Let's implement the other things as well, that is rpush. So we'll copy it, we'll paste it and update few things. rpush, rpush. Okay, let's implement lpop. So lpop, uh, let's do this thing. So db.lpop, it takes a key and we'll receive a key from here, and we'll simply do await and we'll return this thing. But you know, this pop method, it returns us the on the string value, right? So we need to do something over here so that the user know that key has been deleted. So we need to change something. We can do something like let del is this, then we can simply, we already have implemented something like this because it's an option, right? So we need to implement something like this. If let some value, sorry, await and value dot length and value and all right, otherwise this. Okay, let's remove this thing and do something like if. So we'll have some value, right? So db dot lpop, it takes a key, and on the else part we can do something like this, and on the part we can, let me just format it. All right, so we have some value. So what we are going to do over here is, so we are going to do something, and we have value dot length. You know what, let's just copy this thing, value dot to string and none, this thing, where is that get thing? Yeah, let's copy this thing, because we can, because this is returning the option of the deleted popped value. So I think we can do this, or it is an opaque impl future, so let's await it. All right, and for rpop we need to copy this thing. We'll do an rpop. So I think we have implemented lpop, lpush, rpush and all. Why don't we, should we try that thing? We need to implement range as well, right? So let's implement our last function, that is l range. So we'll receive some index like start index and a key. So we'll receive this start and end as a string slice. So we need to parse it on usize that we need. So let's say let list equal to start dot parse. We need this, right? Dot in case we receive any error, invalid start index, and we'll use and dot parse. Let me just copy this thing. All right, now let's do, because it will return us the list, right? So we'll do db dot l range. We have start and key, and we'll await it. let's handle the else part first. Quickly copy this thing, paste it over here, and over here we'll receive an optional vector, right? So we need to create a response so that user know that how many items are there on the list and what are the items between that range. So we'll do is we'll create a response variable. So we'll do something like format. We can do this thing. Let's copy this thing. We need to do some tweaking over here. We only need length, so this will be a list. And all right, what we need to do now is that we have list, so we will also push the items that are available on the list on the response. So in list response dot push, and we need a string over here, so we'll do format and item. And what we'll do is we will, okay, let me just do it over here, response dot push, and we'll do something format, and we'll do item dot length and item, and after this we'll simply say okay and a response. All right, so found this, let's rename it to start. All right, so we have implemented all the like functions available on list, that is lpush, rpush, lpop, rpop and range, and we have implemented its functionality on our database file as well. We initiated this thing on this struct and on the new function, and based on the command that our command parser receive by the user, it will redirect it to appropriate handler over here. Let's build this file. It will take some time and it will be a success. So it's built successfully. Now let's run this file. So for that, let me open terminal. So let's go document and do cargo run. All right, so let's open another tab and let's say telnet 7635. All right, so okay, we have connected over here. Now let's test out our these features like lpush, lpop and rpop and range and all. So we are imagining we will do something like lpush, let's say key called my list, and our value is weapon. All right, let's do another push, lpush my list. All right, let's do another thing, lpush my list random value test. All right, now let's find out the range we have. So what we need on my range, let me just go over here. So we need start and a key. So because on start we will exclude the 0, like the first start, and do something like that. So we'll do 0 to 3 and the key is my list. So as you can see, we have received 3 items, right? 1 2 3, and these are random value test, Joshi, and these 3 values. So we have length over here as well, 17, 5 and 5. So now what if I do something like L range 0 3, do something my list 2, some different key, we are receiving okay. We are not receiving any error or anything, but we are receiving okay. Why? Because here we did this thing, right? So we can do something like not found. So we need to just, I think, kill this server. Let's do something called L range 0 3. Now I think my list, so you can see not found. So as you can see, we have implemented these features of list, that is lpush, rpush, lpop and rpop. So if you want to see how like Redis shows these options, you can validate over here, Redis lpush. So in order to match the format like this, lpush my list word, lpush my list hello. So as you can see, it is storing these string values with this key as a my list, right? So this 1 2 is returning the length of the, so you can format this thing. So we have this L range over here. So L range our key, so it's returning hello world and all. So you can format your response according to this by taking like reference from this documentation page of Redis. So the main motive of this video is to implement these features like lpush, rpush and lpop. Instead of the format actually matching it with the Redis, we have already implemented these things, so only the format needs to be mapped. That you guys can do taking reference from the documentation. So the main point is that we have implemented lpush, rpush, lpop and rpop. Now let's move on to the next data structure. What we have is we'll implement sets over here. So let me just do this thing, Redis as add. So we will implement something like this, as add, as remove and all. So as add a key and a member, right? So we'll do something like this, as add my set hello. So it will store this hello onto this set, and we will implement another thing called as members, so that we will receive all the members from it. We will also do something called as is member and all. Let me just quickly show you what we are going to do. We close this thing. So we have implemented our list. Let's move on to this sets over here. Let me just create another thing. Yeah, so on sets, what we are going to do. So again, as I showed you earlier, that Redis provides some features like as add, as remove, as members and as is member. So we will implement all these things, and to achieve this we will use a data structure called hash set. We'll use this thing. So what a set is, it is a collection of unique elements, right? So we'll use this hash set over here to achieve these things. So we'll implement all these features like as add, as remove, as members and as is member. So let's quickly go on the code base and start implementing this thing. Mostly our let me just go over here. Mostly all these things, the way of doing this thing, like first of all we will implement our sets and data structure will be same. So I will like code, and after once I finish this, then I will walk you through what I have done. Let's start implementing sets over here. So as we have implemented a list, now let's go over here and do something like this, our sets. So we'll do public set hash set, and it will take a string. Okay, now do implementation of this over here. So our sets, again we'll do something like so. On the set, as I told earlier, we have something called as add, as remove, as members and as is member. So we'll implement all these things. So let's start implementing this thing, public function as add, and it will take this and value. So we'll return a bool from here, and this set provides this thing called self dot set dot insert, right? And it will insert a value and return a bool value. Let me just copy it to implement for REM. So if we are taking help of this already available data structure like hash sets, vecdq, hash maps and all, it becomes quite easy to implement these Redis features. So instead of implementing like these doubly linked list and hash sets and all from our own, so we'll do SREM, and it also provides a value called remove. It will remove and it will return a boolean value, but this I think it needs a string slice. All right, so we need to implement as members over here. So we'll do public function, again it will take so we are receiving as members, right? So it will return vector of these string, and what it do is it will self dot set dot writer dot collect. Okay, all right. So another thing that we need to implement is member, right? Is member. So it will take a key because we'll search it with key. It will be a string and it will return a bool, and we need to do something like self dot set dot contains a key over here. So it will I think return a bool needs. Alright, so as you can see, we have implemented these set features like as add and all. So let me just go over here. What all features are there on this Redis set operations? So we have as add, SREM, as is member, as members, and as return the set of member whose two sets have in common, that is intersection. Okay. So for now, I think we are going to. Okay. So these are the data types that we have. So for now, I think we are going to implement this add, remove members and is members. So we have implemented these data structures over here. We are using hash sets. Now quickly implement these things over here on the db file. After that we will modify our command parser. So we can say set, let's copy this thing, right, set. All right, so let's implement set functions from here. All right, so we'll do, that is self, a key and a value, and it is returning a bool. What it does is it will of course do same thing like map. Will do something self dot set dot right dot weight, and we'll do something called let's set equals set map dot insert. Do we, or we need to do some in like this entry key or insert with, we have our set, so we can do set dot add a value. Now we have implemented add. Let's implement these features as well, SREM. All right, so we need to change this thing to RAM. This thing will be same. We need to add few things over here. We'll do something like if let some value, and it will be set set map dot this thing with key, or else we'll do false. Okay, we need to change these things to do something like this. So if we receive any, we'll do something like, let's do this set dot srem will have value. Okay, we need to change this data type as well. It will be a string slice. All right, so we have add srem. Now we need to do SMEMBERS and is member. So we'll do public async fn SMEMBERS. It will take a self and a key, that is string. It will return option of vector of string. So again this thing will be common in this, so we'll copy this and we'll do something like if let some set set dot get mute key, set map dot get mute key. We'll do something like set dot s members, and we'll return something like this, and on the else part we'll do none. Okay, so this is the s members. Now let's do s is member. So let me just copy this thing. It will be same for everything. So async fn s is member. So we will have self and a key, that will be a string slice, and a value. Oh god, and a value, that will be a string slice. It will return a bool, right? Let's paste this thing over here, and we'll do something like set equal to set map dot get mute. We have a key. Let's perform this else first. Let's return, if it's not available we'll do false, and if it's available we'll do set dot is member, and we'll do pass a value. All right, so we have s members. So we have implemented all these features that we have created on our data structure: sadd, srem, s members, and s is member. Now let's modify our command parser. Let's do something over here, and that will handle our s set operations. So we'll do s add, we'll receive a value, let's say s add, or let's say add, and we'll do db dot s add. We'll say key, it's a string, so we'll do to string, and the value will also be a string, right? And what we need to do now here is need to do something like this. Okay, dollar slash r slash n will do something like if add will return 1, else will return 0. But again this thing it's need to be in format macro. Yeah, let's copy this thing and work on remove as well. Let me just quickly do this. Okay, so we have rem, right? While removing we will have a key and a value, right? And we'll do something like SREM. So let's see what it takes. It takes a string slice of key and value, so we need to, let's remove this thing. Now it will return a boolean value, right? Okay, that's fine, that's fine. Now let's do SMEMBERS key. Based on that key we'll fetch who are the member of that specific key. So we'll do something like this as members we need to implement something similar to what we did for this range part. So we need to yeah, we need to make some response out of it, because we will receive a list and we need to show user what all available items are there. So I think instead of yeah, we need just copy this and let's just paste it over here. Let's do some changes. So we have a list over here, right? And instead we'll do s members. Instead of this start end, we'll simply send a key and we'll make a response and we'll have item.length and that item available. Awesome. So we have s members implemented. Let's implement is member. So we have is member and we will have a key and a value. Again it will be something like this. Let's copy this because it's returning a boolean value. So instead of this thing we'll use as is member. We have a key and value, so instead of writing this value we can say it member. So this is the value that we will check for. We'll do something member and instead of this we'll say is member. Copy this thing, we'll replace it with is member. So okay, so we have implemented all these things that are available for set add, SREM, SMEMBERS and is member. Let's make it as is member. All right, now let's build this thing cargo. Oh sorry, let me just quickly guide you through what I have done. On the data structures file we have implemented hash sets, right? Hash set to replicate the SAD, SREM, the sets features of Redis, that is SAD, SREM, SMEMBERS and is member. And we have like these options, right? Insert, remove, and we iterate it to collect them in a vector, and we will show it to the user that how many members are available for that key, and as is member if the member that is present on the set. And once we added these on data structure, we quickly implemented these functionality on our db.rs file, so that as soon as we parse the command entered by the user, we will redirect it to the appropriate handler on the database.rs file. Let's build this thing. So I think it will be like the build will succeed. All right, it's good. Now let's open our terminal and start running this thing. So let's close this thing first. Clear out our terminal. Let's do this thing as well. We'll do a cargo run, and again on here we'll connect it with telnet. All right, now let's do as add let's say my set and we'll do something like within, and again add some more values to this key as well. My set this. Now let me add another thing with my set to test value. All right, now what if I do SMEM S members on my set? So as you can see, on my set I have added Vipin and this text over here, Vipin and Joshi. So if I do a S member on my set, I'll get this, and if I do S members on my set 2, I'll get a test value, right, with the length, and the length of this string value, that is 12, and the length of this entire members on the set, that is 1. So we have here on my set we have two members, Vipin and Joshi, like this. Okay, now let's check our another command, that is s is member. So for s is member, what it needs is, it needs a key on which we will check, let's say my set, and we'll check out a value over here, that is, let's check if Vipin is available. So it's 1, right? That means we have returned it 1, right, on the command side, because it is available, right? This is member. So if this member is true, we are returning 1, else 0. So maybe we can do something like this. Yeah, present, or maybe found, and we can do something like here not found. Yeah, so this way, instead of 1 and 0, we will receive found and not found, right? Okay, so as you can see, we have implemented the list and sets over here, and these are very simple to implement because we are using the already available data structure like hash sets and vecdq. So one thing that you can implement by your own are the hashes. So it is simple, it requires hash map. You will need to implement hash maps over here. Let me just show you. So instead, just like the way we implemented our sets like hash set, you can go for hash maps, and you can check out what Redis provides for hashes, and you can do that as your takeaway work.